Hi everyone, thanks for joining us. I'm Niall Buchanan with Broadcom, and I'd like to welcome you to our sessions today on the topic of workload automation intelligence, manage your SLAs across workload automation platforms and vendors. There are lots of new and exciting advancements taking place in this space. The focus of today's session is visibility into your critical business applications. If you have any questions during the webcast, please feel free to submit those through the chat window, and hopefully we'll have a live Q&A session at the end. Don't forget to fill in your review of the presentation, and don't forget to contribute towards the NHS charity. Thank you. And with that, I'll start the presentation. Thank you.
Hello, and welcome to today's session on using atomic automation intelligence to manage your SLAs across workload automation platforms and vendors. I'm Jennifer Chiswick. I'm the head of product for atomic automation intelligence at Broadcom. The first thing I wanted to focus on is to reinforce the idea that what we're really trying to do with automation is deliver a service to our end users. And if you're here watching this presentation, I'm assuming that you have some interest in automation. Perhaps you are involved in workload automation on the mainframe using a scheduler such as CA7 or IWS, or maybe even some distributed schedulers. And in this world of automation, it's becoming increasingly complex. There's multiple platforms, there's multiple vendors, there's cross-platform dependencies between automation jobs. You're often dealing with concepts such as the public cloud and the private cloud, and where to run your actual automated jobs. Do you want to run them in a containerized fashion on a virtualized environment? What about fault tolerance and disaster recovery? So there's a lot of complication and complexity involved in a large-scale enterprise automation solution. And oftentimes, in dealing with these interesting and complex ideas, it's easy to lose sight of the fact that what automation solutions ultimately do is deliver a service to the end user. So with atomic automation intelligence, we can help you to deliver this service reliably, with visibility, with predictability, and of course, in less time and at less expense. We're also going to talk about how automation intelligence can help you deliver changes to a service. So once you've already have a complex service, an automated service that's been running in your production environment, and you need to update it with some enhancements, how can you do that with confidence? So these are the topics that we'll be discussing in today's session. Let's first talk about how you can deliver a service reliably. One of the first steps in being able to deliver a service reliably is to be able to untangle your business processes. So in these complex and workload automation environments, as you're probably aware, you have often hundreds of thousands of individual jobs with often very cryptic names. If they're mainframe jobs, they may have 8-character uppercase names that really make little sense to a business user, and they're also not associated with any particular line of business. So the first step into reliably delivering a service is being able to identify what components are part of the service and associated with a particular line of business. So that's the first step, and then of course the next step is to have some type of success criteria for that service. So now that you've identified the service, you've associated it with a line of business, when do you expect it to complete? What would be a successful execution of that service. So that basically means assigning an SLA. And whether the customer to the service is an external customer or an internal customer to your business, there is an expectation of when they would like it to complete. And in some cases, that's going to be at a specific time of day. This service, perhaps you have a service that delivers a file that's required in order to open up your trading floor if you're in the financial services sector. And that file has to be delivered by 4 a.m. or else it will be impossible to open the trading floor, as an example. So you would have an SLA established at 4 a.m. You may have other types of services, though, that are running multiple times a day. Maybe you're processing trades, and you basically process them in batches every hour. So you may have a service that runs on the hour every hour, and you expect that it should be able to complete within 30 minutes. So in that case, you would want to be able to establish your SLA based upon the duration of the service. And that should be an option as well. Once you've established your SLAs and you've associated them with the line of business that SLA services, you're going to want to be able to report on the success of that SLA over time. So in order to have confidence that you have a reliable service, you need to be able to accurately say that that service has been delivered on time, X percentage of the time over the last 90 days. So that requires historical data and a good reporting engine that allows you to take a look at how those SLAs have been performing historically. This is just an example in the slide of one of the reports within Automic Automation Intelligence, which will show you all of the different executions of a particular business service and whether or not they made or missed the SLA over the last 90 days. Of course, all of these parameters are customizable in the report. So the next component to being able to successfully deliver a business service is to have visibility into the service and all of its components. So inevitably, what happens in large organizations is through acquisition, through innovation, etc., you end up with multiple workload automation engines. And those workload automation engines are typically communicating with one another through various mechanisms that have been ingeniously derived by various engineers over time. So there's not often a scheduler provided or a vendor provided solution to connect jobs from different workload automation engines together. So you may, for example, be running IWS Z on the mainframe and use AutoSys on the distributed side, and you have some need to communicate, to have one of those mainframe jobs kick off a distributed job, and then in turn have a distributed job kick off a mainframe job. So various ways have been innovated for people to make this happen outside of a vendor supplied solution. And for example, you may have an AutoSys job that drops a data set on the mainframe, and the arrival of that data set would trigger an IWSZ job stream to start, or a CA7 job stream to start, something like that. So because that's not managed by the vendors, it's very difficult to have visibility into that service from end to end. So that's one of the areas where Automic Automation Intelligence really thrives. You can see here in this slide the various automation engines that are supported within Automic Automation Intelligence. We've got CA7 on the mainframe and IWS on the mainframe. We're currently in development and expect to release support for ESP and for Control-M on the mainframe in the next 12 months. And we also are going to be supporting D-Series on the distributed side and Control-M on the distributed side. We currently also support Tidal and Autosys on the distributed side. So these are pretty much the market-leading automation engines that are available today. And in some cases, you may also have, as part of your automation landscape, external applications that run outside of any automation engine. So that's another important aspect of gaining full visibility, is to be able to bring in those external jobs and connect them with your existing automation engines to see a full picture of your entire automation landscape. So how can we do this? How can we have visibility across vendors and platforms when those dependencies do not exist within the underlying schedulers? Well, this is, I realize, a slightly small screenshot, but what this is trying to illustrate in this screenshot is an example of a situation where you have an Autosys box that has several jobs in it. The last job puts a data set onto the mainframe, and then that data set triggers the subsequent CA7 jobs that you see in the Gantt chart. So what we're able to do through Automic Automation Intelligence is create a link between those jobs. We actually call it a custom dependency. It's a dependency that exists for purposes of visibility, reporting, traceability, so that you can actually trace the critical path from platform to platform and from vendor to vendor without losing any continuity. So it's really essential in these complex environments to be able to have these custom dependencies that link together for purposes of reporting and visualization. Even for predictive monitoring, it becomes really important. So you may have a job that one of those Autosys jobs could fail, and because we have this connection through this custom dependency, we can actually send you a predictive alert that your SLA, which is on a CA7 job downstream of the Autosys job, is going to be delayed, or actually may not run at all because the Autosys job failed. Similarly, if one of the Autosys jobs ran really long, a lot longer than it usually does, you would be able to get an alert saying that your CA7 job is predicted to be late. It's predicted to miss its SLA. So having this visibility is, again, a key component to being able to deliver an effective business service. And to extend that visibility, you often will also need to extend it into external applications. So this example is showing you a situation where you have a particular set of jobs. They can actually be on any platform. Perhaps it's CA7, perhaps it's on the distributed side. And one of those jobs that's in the flow will call out to an external application that's not under the control of any workload automation engine, yet it runs perhaps a set of 10 or 20 jobs that are critical. And when that last job finishes, it goes back and calls into your automation engine to start a job. So up until now, that exit off into that external application has really been a black box, and continuity and visibility was lost from the point of view of monitoring a business process. So now, through AAI, we're able to actually connect through to see that dependency and trace through all of the jobs within it from this automation engine to the external application and back again. So bringing that external application into the landscape is another key component of adding visibility. The next important topic to discuss in terms of being able to deliver a business service effectively across vendors and across platforms is predictability. It's so important that as your business process begins executing, you have a sense of if it's going to be early, on time, or late. And if you can get early warning that your business service is in jeopardy of not making its SLA, you have an opportunity to take actions to either get it back on track or to notify the appropriate end users of the service that they can expect a delay. It gives you options if you have some early warning. So the predictability is important in and of itself, even within a single automation engine, but it becomes even more important when your business service is crossing multiple vendors and multiple platforms, and you want to be able to predict all the way through that. The other things that you may want to do with prediction, and of course all of this is available within the Automic Automation Intelligence platform, is you would want to do some type of what-if analysis. So if you're monitoring a business service and you get a prediction that it's not predicted to finish because a certain job has failed, you may want to say, well, what if that job that failed was restarted right now? Will I then be able to make or miss my SLA? So being able to do that type of what-if analysis is also really important. Or you may know that today is a particularly high volume day. So there's certain jobs that are within your application that you know are going to run 20% longer than they usually do. So you would want to be able to feed that into the prediction engine and say, okay, what if these jobs that typically run for an hour today run for an hour and 15 minutes? How is that going to affect my SLAs? So that type of what-if analysis really helps you gain predictability and visibility into your business services. The other key to predictability is if we predict that something is not going to run, it's important to know why. So having a root cause of the reason something is not predicted to meet its SLA is also really important. You may have a root cause of a particular job has failed, or maybe several jobs have failed, and all of the failed jobs need to be restarted in order to get back on track. So that's one potential root cause. You may have a situation where somebody put a job in the middle of your business service on hold, and that's preventing you from being able to make your SLA. So being able to identify those root causes and associate them with the business service, because again, that very first step that we talked about when we were talking about reliability is associating these services with business areas or lines of business. So now, if a job fails, it's not just failing in a vacuum. You can now say, oh, this job failed and it's going to affect the following 5 business services. So it puts the failure in context and gives you a business effect of that failure, instead of just a random job that fails that you don't really understand what the implications of that failure are. And then, of course, as you're monitoring and predicting and dynamically recalculating the predictions based upon what's actually happening, it's important to have good alerting to let you know via SNMP or email or even through a subscription service that you are in jeopardy of missing your SLAs. So multiple alerts with different distribution mechanisms is also a key component of the Automic Automation Intelligence platform. In addition, whether you're using a mainframe automation engine or you're using a distributed automation engine, you are likely going to schedule work to run on multiple machines. So from a mainframe, you can schedule work to run on using distributed agents. Of course, you can do that through distributed automation engines as well. So it's important to understand how your agents are loaded, how many jobs are running on your agents, and also to be able to predict what jobs will be running on what agent at what time. This can be used for predicting load contention issues. So if you want to resolve some load balancing issues, you may have one agent that's running 80% of your processing and another that's running 20. So to have that type of visibility and also predictability is really key. You may also be in a situation where you want to take an agent out of service, and you want to take it down for an upgrade, let's say at 1 in the morning. So it would be really useful to be able to predict what jobs will be running on that agent at 1 in the morning, so you understand the impact of taking it out of service. So that type of predictability is also available through Automic Automation Intelligence. In addition, we can also predict resource utilization. So if you make use of counting resources within your automation engine, you may have virtual resources, different engines, name them different things, but basically it's the concept of having a virtual resource that has a maximum limit. And then certain jobs are defined to use that resource in some increment. And when the resource has reached its maximum, because there are enough jobs that are using it, that it's reached its maximum limit, no more jobs can run that are associated with that resource. So so that can also cause some delays within your business service. So you may not realize that your business service is actually being delayed because you have a job that uses a virtual resource and it's waiting on that resource. So through predictability, you can now predict what jobs will be using a certain resource at a certain time to try to understand if there's going to be any contention issues for that resource. You can also look at it, this slide is about predictability, but you can also look at it historically to try to do some post-mortem analysis. You may want to understand what jobs were using a virtual resource at a certain time of day in order to troubleshoot where you may have some bottlenecks that you can remediate in your service. And predictability gets difficult in some situations. There's certain rules that we can use to predict how your business service is going to run, and we've talked about a few of them. So, for example, understanding the custom dependencies between jobs that are not in the same scheduler is a key to being able to predict across platforms and across vendors. But even within a single vendor, a single platform, within let's say CA7 on the mainframe, you may have thousands of jobs with various dependencies. So in order to predict, of course, you need to understand the dependencies between the jobs. You also need to understand any calendaring conditions. This job runs on the last Friday of the month, that kind of thing. And also understand the virtual resource usage. There's a lot of factors that go into it. And in addition, one of the key components to being able to predict accurately is to be able to have a good statistical algorithm to determine how long you expect each job to run for. So a combination of the predicted duration of the job with all of the scheduling rules allows us to predict very accurately how we expect your business service will will run. But there are certain times when there is something that's unpredictable. Everything I just described is actually relatively predictable. There are defined rules, defined calendars, defined hard start times, defined virtual resources. We have historical data to help us understand how long jobs are going to run for. So it's complex and difficult, but it is predictable. Where things get unpredictable is where the rules are not defined within the scheduler. So you may have a situation where there's a certain job within your automation engine and it runs every day at 5 o'clock, but you don't know why. It doesn't have a hard start time, it doesn't have a calendar, it doesn't have any predecessors. There's nothing that indicates why that job is going to run, yet it does run every day at 5 o'clock. So that is, in a way, unpredictable. But in fact, we can detect that pattern. So that's another one of the machine learning types of algorithms that we put into play within Atomic Automation Intelligence, is to be able to look at all that historical data and determine that there is a certain job that doesn't appear to have any starting conditions, yet we notice when it runs. It runs Monday, Wednesday, and Fridays at 5 o'clock, and it runs Tuesdays and Thursdays at 7 o'clock. So if we can detect that pattern, then we can predict it. So we can create what we call custom start times, which allow us to predict those unpredictable start times. And then once we can predict that job, then we can use all of our other algorithms. You know, we know what the successors of that job are, so we can predict all of its successors and allow you to gain visibility. So this type of thing will happen if you maybe have like an external event that's running outside of the scheduler, and every day at 5 o'clock it triggers a job. So it looks unpredictable, yet that external event is actually running with some predictability. So that's one area through using machine learning where we're able to predict the unpredictable. So that's a constant area of advancement and interesting application of technology. So the next thing that you want to be able to do using an analytics platform such as Atomic Automation Intelligence is to be able to use the platform to identify where the bottlenecks are within your applications so that you can streamline them and you can get them to run in less time, which is usually at less expense. So having good visualization tools that show you the critical path through your applications is really key to being able to identify bottlenecks. You know, if you have a business service and the example that I gave earlier, where a file has to be delivered by a certain time, perhaps 4 a.m. Well, there may be literally thousands of jobs upstream of the job that delivers that file, and if you're having a problem and that file is being delivered late, or it's looking like it's starting to creep up over time and will begin to be late, it can be a daunting task to try to figure out those that sea of dependencies and where you can optimize to get that SLA to come in earlier. So understanding the critical path is probably the most important thing you can do in order to optimize that service. So the critical path is the single path through the entire business service that took up the time from beginning to end. It's the long pole in the tent. And if you can look through just the jobs that are part of the critical path to the target job that you're interested in, you know where to focus your optimization efforts. You may find that there is a job that's in the critical path every day that's running, for 4 hours, and maybe it's been trending longer over time. So that's, really finding a needle in a haystack is identifying that job to know where you can focus your optimization efforts. And the critical path can change from day to day. So it's really important to have enough historical data to understand what jobs are in the critical path the most often, and actually the ones that run the longest are typically also important. The jobs that are in the critical path most frequently with the longest duration really helps you be able to pinpoint where you want to focus your optimization efforts. You may also find when you're looking at your critical path that you have delays that are built into your business service. Maybe they're designed into your business service, or perhaps they are the result of what we were discussing earlier, which is resource contention. So a design delay may be a situation where you've got a job that has several predecessors, but it also has a scheduled hard start time. So all of the requirements may be met for that job to start. All of its predecessors have completed, but it still can't start until its hard start time happens. And sometimes, that's designed, that hard start time is important and it was placed there for a very good business reason. But other times that can be an artifact of a legacy system, or somebody, incorrectly put this fixed dependency where it wasn't really necessary. That could be putting a delay in your critical path. So being able to discover and understand those design delays can really help you optimize your services. And then the resource delays as well. You may create these virtual resources with their maximum limit and not realize that your batch is being significantly affected because jobs are waiting for those resources to free up. So you may be able to re-engineer a little bit, maybe add more capacity to that virtual resource, or move jobs around to different virtual resources so that they're not all competing for the same resource. It's very important to have the analytics that surface this so that you can make these decisions in an informed way. And then the last thing that I really wanted to talk about today is how you can deliver changes to your service with confidence. So it's once you have your service running, and as we've discussed, it can be quite complex, multiple platforms. One service may represent thousands of jobs. They have dependencies between them, between vendors. There's a lot to keep track of. And now you want to upgrade that application or that business service. You want to put a new accounting system in, for example, and that's going to represent 100 new jobs and changes to existing dependencies between jobs. And you want to be able to insert this into your very complex automation system without affecting your SLAs. So one way to do that, which we offer through the AI platform, is to do simulation and modeling. This allows you, and this is a feature that we recently rolled out, and we're rolling it out for all of the different automation engines that we support over time. But for now, this example is with AutoSys on the distributed side, where you can provide to Automic Automation Intelligence the proposed changes that you're planning on making to your business service. So this means the job definitions that you're planning on adding with their dependencies, and any changes to existing dependencies for existing jobs, as well as anticipated durations for how long you expect these new jobs to run, or maybe any changes in duration for existing jobs, and be able to press a button and be able to simulate that and see if you were to implement these changes, would it affect your SLAs? So that can really give you a new level of confidence prior to moving changes into production that they're not going to have a negative effect on your existing services. So, ultimately, where you want to get with this is to be able to make this part of like a DevOps process, where prior to moving any job definitions into production, you would run a simulation through the DevOps process and validate the results to get a green light to say, yes, you can now move forward with these changes. So that's an evolving area of technology that we're offering through the Automic Automation Intelligence platform. So all of the topics that I've discussed today are what we're striving to accomplish to help you be able to deliver your services more reliably, more predictably, and with visibility, faster and at less cost, and with confidence, using Automic Automation Intelligence, and taking into consideration the fact that these services do cross vendors, cross platforms, and even involve sometimes external applications. So thank you for your time today, and if you would like to more information, please feel free to contact me. You can reach me at jennifer.chiswick@broadcom.com. Thank you so much, and enjoy the rest of your conference.